So this is much better. We actually can see our pattern running. We can see that ESP has a bunch of our pattern there, EIP. So this helps because from here we can actually get an offset. In order to run the pattern offset script, we actually need to display our value at the top of the stack, which is ESP, right? So we're going to display what's in ESP. Okay, and our value here is 41, 68, 41, 41. Okay, so then all we need to do is use the pattern offset, feed in this value. Okay, and our offset was found at 100. Great. So let's take a look at the next iteration of our exploit code. So since I know the offset is at 100, I'm actually going to assume that EIP is 4 bytes down from that. So I'm going to take 4 minus 100, which is 96. So I'm still going to make 96 A's, but I'm going to try to overwrite EIP with the letter B repeated. Okay, so this is really what I'm trying to get to. I'm trying to get to the point where I'm overwriting the EIP so that I can control it, obviously, to send in my a memory location for my shellcode. And then I just added some C's to give us some space. Now this is going to write everything out in in2.txt. So I'm going to read that in. Okay, and we have good news. I am able to successfully overwrite EIP with my B's. So now what we can do is we can actually put our shellcode in an environment variable and run it through this program called getEnvAddr. Now what this is going to do is basically tell us the return address that we can use for EIP in order to point to our shellcode. And apparently this is a common piece of code that's been passed around the internet. So anyway, have it here, and we're just going to create an environment variable that we're then going to plug into the C program, but basically it'll spit out that memory location that we need in order to feed to EIP. So let's go ahead and take a look at that. First, I want to show you the shellcode. I'm running a 32-bit instance of Kali Linux here, and because of that, the shellcode that I'm using is meant for 32-bit. I just picked something up from Shellstorm, but it seems to work great. So what we're going to do is we're actually going to create an environment variable called pawn, and we're going to export that into our environment, and we're going to use Python to help us. So now it's exported in our environment, and we are going to go ahead and execute our getEnvAddr. By the way, the source code that I showed you is .c, so you need to go ahead and compile that, and obviously you need to compile that with the NX bit turned off. So you'll do the same command that we ran earlier against Classic. So now I'm going to pass in my pawn environment variable and of course my binary classic. Alright, so what that does is it gives me a memory location for where I can return from the function and place my shellcode. Okay, great. So I want to grab this value here, And I want to actually go into the next iteration of my exploit script, exploit3.py. And I want to place that value, instead of having the B's, I'm going to place that new value there. Now you should keep in mind that your memory addresses can change every time you do a VM exit. So you might have a different memory address from what I'm running if you're also running 32-bit. But so long as you follow the steps, you should be okay. So now we're going to go ahead and run our exploit script. And so what we can do is just go ahead and pass into our binary classic the n3.txt that we just produced, and pipe it into the binary and just do a cat on that. So what that means is we are actually able to execute our shell code. Now it says no shell for you, but if I do a who am I, you can see that I'm root. So I'm actually at a shiny shell, and I could execute a cat on, say, Etsy password, right? I can basically do any command that I like, and of course I can exit out of the shell. So this concludes the exploit for buffer overflow attacks on systems that have NX bit enabled as well as ASLR. So finally, you're probably wondering, well, what's going to be in part 3 of our malware analysis series? Basically, it's just some more cat and mouse games. We're going to look at virtualization and basically exploits that can be done in there. It's pretty interesting stuff. So I will work on the next series, and hope that you can watch that and enjoy that material as well. And then finally, I just want to provide the references that I used for putting this series together, and thank you very much for your time.